so workplace 20, let's just talk about the second part of this 3.1 here. We're talking about nets, okay? We're not talking about nets that we catch fish in, but we're talking about three-dimensional figures that if you were like to cut them up and lay all the pieces flat on the table, what would that look like? So we did a little activity where we sort of tried our best without looking ahead to try and figure out how we could make a three-dimensional figure with one piece of paper, right? How we could cut it up just the right way. So we discovered that cone was a pretty tough one. A cone's net, if you were to slice a cone up and lay it flat on the table, guys listen, okay? Looks like this. It's not quite a triangle because the bottom is rounded here, almost like a triangle. And there's the base, the circle is attached down there somewhere. So that's what a net for a cone looks like. A cube has 6 identical squares. And so if we had the bottom here, and we had 4 sides, and then we had the top, and they were all connected into one piece, the net would look something like that. A right triangular prism, well, we have a base, which we drew right here, and then the 2 triangles would be attached to that base, okay? And then we'd have to have our 2 sides, the red one and the blue one, attached. So this is what a net looks like for a right rectangular prism. And then, of course, we came up with this joke. And Jesus said, "Cast your net on the other side of the boat." Kudos to you, Caleb, for coming up with that one. All right. Okay, so let's take a look now at working with nets. Okay, a net. Okay, a net is a 2D pattern that can be folded to make a 3D shape. So it says right here, a 2D pattern that can be folded to make a 3D shape. Okay? Now, what nets can help us with, because can someone grab that door, please? You can tell them to be quiet out there too if you want. All right, so nets are really going to help us find surface area for things. Okay? So if we have something like this looks like, I don't know, what is this, like a birdhouse or something, or like a little model house or something. So if you want to find the surface area for this particular object right here and how much, let's say, material that you would need to build this, then you'd want to find surface area. And it might be a little tricky if you don't have the object right in your hand. It might be a little tricky to figure out how many sides there are and what these sides look like. And so if we're to be able to draw a net, then we would be able to identify how many sides there are and what the dimensions of those sides would be. So let's take a look at this particular object. You want to open up your notebook there, okay, your workbook here, to this page. And that's going to be, page 134. This is what the net diagram looks like. I'll just zoom out a bit so you can see it both there. Okay, so here are the ends right here. This looks like kind of like this, like a square with a triangle on top of it. There's 2 ends. There's a base, there's 2 sides, and then there's actually 2 sort of pieces of roof right here. So this is what this net looks like. Now, when we have the net drawn, we can actually start to label the lengths of all the pieces of the net, and then we can start to identify what it is we need to take the area of. So for example, this is 30 in length. So that's going to be this right here. And I'll maybe mark that down on there. From here to here is going to be 30. Does everyone see that? 30 there. This is 10, like this right here. 10 up there, so that's 10 right there. 10 right here. And how do we know that this is 50 right here? Well, because each of these are 10, right? And there's 5 of them. 10 there, 10 there, 10 there, there and there. So you can start to kind of piece together things. So look at what they did. In order to find the surface area, it looks like they actually took this as one big rectangle. One big rectangle. A width here of 50 centimeters, see? Or a width or length, whatever. And then this other dimension is 30. That's this length right here in the diagram. Okay? So really, we have big area 1 here, and that's 30 times 50. That's going to be what, 1,500? Okay, 1,500 square centimeters. Then what we could do is take a look at the 2 ends, and you know what I would do? I would probably split this up into a square here and a triangle. Okay, so let me zoom in there now just a little, whoops, other way. Let me zoom in on that a bit so you can see that. You guys all see that? There's a square and a triangle. Just like over here, a square and then a triangle. So if we're calculating the area of this, we have area 1. Let's say this is area 2. This is area 3, and those are going to be the same. Area 4, area 5. So area 2 is 10 by 10, or 100 centimeters squared. Area 3 is the same, 100 centimeters squared. Area 4 and 5 are going to be the same too, but area 4 and 5 are a little tricky because they're triangles. Do you remember what the formula for a triangle is, anyone? The area for a triangle? Very good. Base times height divided by 2. That's exactly right. So area of a triangle is base times height over 2, or 1/2 base times height. Same thing. So that's very good. Now, do we know the height, though? Eesh. We know the side length and we know the base, but do we know the height? Ooh, are we given that in the diagram anywhere? Let's see. We aren't. We aren't given overall height or anything. So we're running into a tricky part here now. Do you know why? Because we have to find out what this length is right here. And if we have a triangle like this, where this is 10, this is 10, how do I find the height? Notice that that's a right triangle right there. Anybody have any idea how I could find this length right here? What's the theorem that we would use to do with right triangles? A squared plus B squared equals C squared, and that is, you know what that's called? Pythagorean theorem, right, exactly. So this is how it's going to work. We're going to have a right triangle where I know that this is 10, and this actually is half of 10, isn't it? Because I just want to focus on this part of the triangle. I need to find this height. So there's going to be maybe some other work that you're going to have to do on the side in order to do this. So let's say h squared plus 5 squared equals 10 squared. That's a squared plus b squared equals c squared. So what do I have? I have h squared plus 25 equals 100. I'm going to subtract 25. I'm going to have h squared equals 75. And do you know how to find h from here? Square root. Very good. So we get on our calculator. Maybe you guys can help me out with this, please. What's the square root of 75? Make sure your calculators are smart enough to do that.
25.
Not square root of 25. Square root of 75.
8.6. Yeah.
Okay, 8.6. I think that's right. Do you know why I know that that's probably pretty close to being right?
What?
What's 8 squared? Do you know? What's 8 times 8? 64. What's 9 times 9? 81. So is 75 between 64 and 81? It is. So 8.6 makes a whole lot of sense. All right, so we found that out. So area 4 now is going to be 1/2, or this is the way I'm going to do it. The base is 10, right? See, the base is 10. And the height is, 8.6. So what's that? 10 times 8.6 divided by 2 is going to be 43? 43 centimeters squared. And of course there's 2 of those. So what we do now that we have all of the pieces from our net, I have this one, I have this big one, I have this one and this one, you can just add them all up. 1,500 plus 100 plus 100 plus 43 plus 43, and that's going to be what? Being 1,786 centimeters squared. Does that look right when you add up all those? So this question just asked us to draw the net, so we didn't have to find the area, but this is a question that we're going to have to know how to do here soon. So I kind of did a little bit even more than we needed to do for this one. So let's work on build your skills. Okay. Oh, that's interesting. Can you imagine what the net of this box would look like? Interesting. Well, you guys can think about that. Maybe you guys can draw that in the margin of your book. Okay, so let's draw the net for these two things. Okay, so do we have, is this a cube or is this a rectangular prism? It's rectangular. Why is it rectangular and not cube? Do you know why? It doesn't look like a cube, right? So these two lengths are the same. But not all the sides are equal. Yep, not all the side lengths are equal. If they were all equal, it would be a cube. It's not so. So let's see, the base is going to be a rectangle. Excuse me. And what are the dimensions going to be? What's the height here, like this long part? How much is that?
15.
That's right, it's 15. And what's the top part? Well, it's going to be 5 here, isn't it? Okay. So that's the base. And so the base, if I can picture that base, that's this, right? So there's going to be 2 rectangular sides that are the exact same, aren't there? So I'm going to draw those 2 sides as best I can to be the exact same. So that's this front side and then the back side there. And now we need to focus on the 2 ends, I guess. So the 2 ends, let's see, that's going to go on the top and bottom. And those are going to be little squares, aren't they? 5 by 5. 5 by 5. What am I missing here? Sorry? A rectangle? Sorry? The top. Very, very good. Yes, I'm missing the top. So it has to go either on this side or on this side. And you know what? It doesn't matter which side you put it on. It's going to look just like that. Oops. So that's the net. Right on. That's awesome. And you've got some of the lengths marked there, so that's perfect. Okay, does everyone understand that? Okay. Why don't you guys do the rectangular or the triangular prism? I think we did this one already on our first page. I don't know if you copied it down or not, but you can just copy down with the lengths attached to the net, please. So go ahead and you guys can do that. Take a minute to work on that. All right, so yours might look something like this, where we have the 2 triangles on the ends here. That's this one, and then there's one tucked in behind there that we can't see. And then we also have a base right here, and we have a side and another side, side and a side, and that's it. So there's the net for that one. Questions about that? Okay. All right. I will let you do. Whoops. Number 7. Number 7 on your own. So tell me which one of these is correct, or if they're both correct, or if neither are correct. And try and explain why. And if you need a piece of paper and you actually want to trace this out and cut it up and see if you can make it into a right octagonal prism, then you go ahead, but take a few minutes to finish that off. Okay, so A is your correct answer for sure, and the main reason why, as was mentioned here, this one only has 1, 2, 3, 4, 5, 6, 7 rectangles, and of course it's 8-sided, so we would need 8. If there were 8 strung together like this, this arrangement would still fold up into a right octagonal prism. So yeah, this one works good, this one is not good. All right, so this is going to be the last example we're going to look at before I kind of set you off on your assignment, which the next part of the assignment, the final part of this day's lesson, is we're using the nets now to calculate surface area. Now I did that example for you earlier. This one is a bit easier because it doesn't have a triangle that we don't have to figure out. So this one is just rectangles. But let's just walk through this real quick. If we had a rectangular prism like this, and we were asked to find the surface area, the net diagrams are very, very, very helpful in helping us organize ourselves. So this rectangular prism, if you were to draw the net, it would look just like this down here. And I'll zoom in on this a little bit so that you can see, here's the bottom right here, here's the top. This is a side, this is a side, this is a side, and this is a side. Okay? You guys with me there? Yeah? Okay. So once you have this, and once you have all of the dimensions from the diagram, see these numbers here, appropriately on here, then you can start to piece together the areas. So area 1 is going to be, it's a rectangle, so it's going to be this dimension times this dimension, right? And then you're going to have that area for area 1. Area 2, oops, area 2 is going to be 1.9 times 3.8. That'll give you a second one. Now, there's actually 2 identical ones. So guess what you could do? You could go, hey, I'm going to go 2 times this. Hey, that's this one and this one. Right? The area 1, there's another identical one down here. So you could actually do this. I'm going to go 2 of those. Now you're clipping this off real quick, aren't you? And finally, area 3, you see there's actually 2 of those as well. And what are the dimensions? 4.6, same as this, times 3.8, right here. And so you add up all these 3 and you get your final answer. Okay? So again, I did an example like this already, actually even a more difficult one, so that's why I'm not doing the whole thing here. But what you can do is you can look at the solution to this, and they kind of tell you this, and this is what we should get for an answer. See, 2 area 1s plus 2 area 2s plus 2 area 3s would give us this as an answer. Okay, so with these questions here, oh, this one's going to be a tricky one, because that's not a square on the top or a rectangle. What shape is that? Yes, trapezoid. We took a look at that last lesson. That's a trapezoid. So that's going to add a little bit of fun to your net diagram. So you guys have the rest of the class, okay, to work on questions number 8. Just question number 8, actually. And then we'll take a look at this one here tomorrow. Okay? So you work on question number 8, using the net diagrams to find surface area.